All right, guys, so we're to a point where we are kind of looping back to where we were at the beginning. So it kind of brings us all back together, gets us ready for a little bit of a review because we are going to be taking like a quiz slash test over this before our school year is over. We do only have a few more days left of school. It's kind of crazy to think about that. And so what we are learning today is half new, half kind of going to relate to us to kind of bring us back to the beginning of the chapter so we can start kind of reviewing. And so the last few days we've been talking about like dot product and cross product, but if you realize I always talked about each of those, and the last few days I said things like, oh, they have their components. So we're going to talk for a few minutes about like components of a vector, and not the vector that's written in vector form, the vector that's sort of a geometric vector, and I'm going to talk about that a little bit too. But finding the components is actually a pretty easy idea. Guys, since we are going to be working with geometry kind of again, you need to make sure that your calculator is in degree mode because of what we're going to do. So real quick, what if we had a 48 meter vector? We knew it was 48 meters and it was going at 55 degrees. Well, my drawing is off here. I don't really care about that. I hope you don't either. But let's say that means this vector right here is 48 meters, and there would be a 55 degree angle right there. But here's the deal. I want to know my vectors. So obviously I know that this went to the right and I know this went up. But how would I find those? Okay, how would I find those? So let me take a few more notes right here. And the only reason I started to put this dashed line is so that we knew it was 55 degrees right there. Instead of making that a dashed line, if I would make it a solid line, sort of all the way to the right. And it's not always going to be the best drawing when you do this, but anybody want to tell me what I wanted to get us right there? Yeah, I'm hoping that that's a right angle. And then if we go right next to 55 degrees, that would be X. And since I said X, X would be the adjacent side. If I go across from 55, across would be Y, and Y would be the opposite side. So again, let me, since it's so close to the bottom of the paper anyway, let me cover this up and just ask you guys like, hey, what if we were going to try to find Y? It's the opposite. We know the hypotenuse. To find Y, I'm going to write it right here. We would find the sine of our angle and do opposite over hypotenuse. But since we don't know opposite, we would rearrange that a little bit, and I would get the hypotenuse times the sine of the angle. Similarly, for X, it is adjacent, so I would write cosine of theta equals adjacent over hypotenuse. And I would get that. So I'm going to come back to this paper in just a minute. Here's the deal. That's at 55 degrees. We know that angles can be anywhere sort of around the unit circle. So what I want you to know is your calculator is pretty smart, okay? Your calculator can handle any angle. So with what I did right here, and that's why I said I'm coming back, if you paused and already wrote that down, remember how I said sine equals opposite over hypotenuse? Well, we know that from forever ago, but look at this. That would mean opposite is Y. 48, remember, was my given vector, and 55 was the angle. And so that's why I want you to always use the following. If you already wrote it down, it's just there, but if not, pause again and write it. In order to find X, which by the way is our horizontal component, you are going to take your vector, that's what V stands for, your given vector, times the cosine of whatever the angle is. And don't even worry about the angle if it's not like a nice angle for a 90 degree angle. I'm telling you, it doesn't matter. Y is our vertical component, and therefore it's going to be V times this, V standing again for the vector times the sine of your angle. And so for half your homework tonight, all you're going to have to do is have your calculator ready and type in things. And here's what I mean when I say that. What if, we're going to do 3 quick examples. Okay. If it is in the quadrant number 1, I think we all know it goes to the right and up. I think we all know it goes to the right and up. But remember, and we're going to need this paper again, depending on what my angle is, I'm in a different quadrant. Quadrant 1 goes right and up. Quadrant 2 should go left and up. So we're going to do a couple examples to make sure we know if we're going to the left and up what that means. So Let's just do them one at a time right here. Even though I have them all, maybe you saw them all. We're going to find the components of a 23.7 meter vector at 147 degrees. Remember, 147 degrees is in quadrant 2. If it's in quadrant 2, what do we know? It goes to the left. So let's try to figure out our x component. Remember, to figure out our x component or our horizontal, we're going to take our vector, which was the number 23.7. But then we have to multiply that by the cosine of my angle. Please make sure, again, just as a reminder right now, if you don't get the same answer I do, it might be because you forgot to check if Desmos was in degree mode. Uh-oh, that's kind of weird. It tells us it is a negative 19.87649. It goes on for a while. Why would my vector be negative? Please remember, vectors actually can't be negative when we're talking about geometry like this. Negative just tells us the direction. The x vector is going towards the left. So we are going to write x equals 19.9, because we real round, meters to the left. So if you get a negative, it means the left. That's what we've been doing the last few days as well. If you get negative, it means the left. And then all we have to do on Desmos, even guys, you can delete the COS for cosine and just type sine in there, or type it in, whatever is easiest. And it does tell us a positive 12.9, but positive means, oh wait, y is vertical, so positive would mean up. So 12.9 meters up. And I'm okay with you saying like to the left and up. All right, so when we have 23.7 meters at 147 degrees, that would be 19.9 meters to the left and 12.9 meters up. So let's try our next one here. Sorry if I haven't let you see it enough already. If you want to write down both of those, I'm probably going to put the paper back up and read through both of them. Let's find out about our 46.5 meters at 200 degrees. All right, so just start over, delete. You're going to do 46.5, and at first you're going to type in cosine of 200 because it's x first is usually easiest. Uh-oh, it's negative again. But guys, that makes sense because I worked my way around. Remember, quadrant 1 goes to the right and up, so those should both be positive. Quadrant 2 goes to the left and up, so horizontal should be negative because you're going to the left, but vertical should be positive because you're going up. 200 degrees is down here in quadrant 3. That means I am going to the left and down. That means both of these components should be negative. So when I get 43.69570, I am going to write 43. I'm going to make it positive when I write it down. 43.7 meters, but then I write to the left. Okay? And then y, remember for y, I just have to change my cosine to a sine. And it says 46.5 sine of 200, once again, is negative, but I'm not going to write it as negative. My calculator says 15.9039366. So I'm going to write 15.9 meters down. And right now, guys, I'm okay with you saying up and down, left and right. All right? Let's think about this. Where is 314 degrees? 314 degrees is in quadrant 4. Quadrant 4 goes to the right and down. So my x component, hopefully when I type this into my calculator, my x component should be positive because it's going to the right. Let's see. 16.8 cosine of 314 does give me a positive 11.67026. So that's going to give me 11.7 meters to the right. And then if I switch the cosine to sine, it tells me that 16.8 sine of 314 is negative, which makes sense because that's in quadrant 4, so it's going down, is 12.0849. So that 12.08 would round up 12.1 meters down. All right, so some of your homework is actually going to be that quick and easy to find the two components. But just to help us remember a few things then too, I'm going to give us a few examples of using those components in geometric form to find the answer. So we're going to be given sort of vectors like this, and I'm supposed to find this. So pause for a minute. I already kind of started this. That's why there's a box with the S here. Our first example today is for Kaylin. All right, so Kaylin walked south, then west. Remember, it is very helpful for us to know where she started. So I'm going to put a little box right here, only because I know she walked south first. That means I'm going to draw my arrow down and then towards the west. And which is also why I put it kind of more near the middle of the page rather than the side. So let's draw an arrow straight down. And let's write the number 7 there. Remember, since it's already down, we don't write the negative or anything like right there. I'm just going to write 7 there. And now I got to draw mine to the west, which would be to the left. And so I have a 7 there, I have a 5 there. What is her resultant vector? Her resultant vector, guys, I don't know how well, this is kind of an aqua color pen. Sorry if it doesn't show up that great on there. Hopefully it does. Yeah, I think you can see it okay. I just don't know how different it looks. That would be her resultant vector. Remember, to find the size of the resultant vector, we use Pythagorean's theorem. This is the part of the chapter, of the section where it's kind of review. So we're going to do 7 squared plus 5 squared equals h squared. Of course, because I was just doing it, we could almost call that v squared for the vector squared if we would want. So let's see what my calculator tells me. 35 plus 25, not 35, sorry guys, I'm multiplying those. 49 plus 25 equals 74. All right, so I'm going to find the square root of 74. It tells me it is approximately, so the vector length is approximately, I put the little squigglies because in some of my other classes I do that. I'm going to say 8.6. My unit was meters. Please remember, a vector has a size or magnitude, so that's the magnitude is 8.6. But now I also have to find the direction. So I'm going to go a little bit more in depth on it today. I know we've talked about it a couple times, but since this is also acting as a review. Guys, we want to find the angle where she started. That's why I always put a box for S. And I know this is a right triangle. I forgot to label it that way. We know this is a right triangle. That means there's 2 other angles I could find in this triangle. But the angle I always want to find is always going to be the angle compared to where the person started. So I'm going to find theta up here. And since I'm finding theta up there, I'm going to use opposite is 5 and adjacent is 7. And so I'm going to use tangent inverse of 5 over 7. Tangent inverse of 5 over 7. So let me click back over to my calculator. Tangent inverse, whoops, got to clear everything out. Tangent inverse of 5 over 7 is telling me 35.5. Guys, I always want angles. It just makes more sense for what we've been working with to always write our angles to a whole degree. So that's going to be 36 degrees. So we got 36 degrees right there. But guys, this is where I kind of had to remind you of a few things our second day of the lesson. 35 degrees would be in quadrant 1, meaning she would be going to the right and up, or west and north, east and north. Sorry, I was looking at this paper. Right here it says she went south and then west. 36 degrees would not mean southwest, not at all, okay? So here's what I want you to think about. Compared to where she started, if I put this up here, and we could kind of put these on top or bottom of each other. I think I might do it this way because I think the permanent marker might show through a little bit more this way. If I were to line these up, which one of these 4 lines does Kaylin's triangle match up with? All right, so this line right here would represent 270 degrees. So if I know that my unit circle starts here, where my pen kind of is, and I rotate all the way here is 270 degrees. Remember, 270 degrees is here, but I'm a little bit good. Guys, when you put that in there, this is why lots of times I like to put that angle mark in there eventually too. And when I do that, I'm asking you, and we usually do this, I usually do this anyway with you, I'm like, what way does the unit circle normally go? If it was going forward, it would go this way, but since my little arc is going this way, that is the backwards way around the unit circle, and that's why I usually put that there as well. So since 270 is my number right here, I have to take 270, and since it's going the wrong way, I've got to take minus that 36 degrees. Okay, so 270 degrees because it's what one of my quadrant lines I kind of matched up with. So 270 minus 36, should be 234 degrees. And so that's why I'm kind of doing these two parts together. Here, Kaylin started out with her two parts and we found our answer together. Earlier today, we started out with the two parts together, kind of the final answer, and found the two parts. All right, one more lesson I would sort of like to, not lesson, one more thing I would like to do just because I know you guys can handle it because you've been working with multiple. Please write down Leah's situation here, and then we're going to do something to help ourselves simplify it. All right, so there was one other day where Erin did something like that, and I drew this big old picture, and the picture was going all around and everywhere and everything. And I said that's long, hard, and confusing to do that. So since we're talking about components today, I'm going to do something and put my paper back up, and I'm going to use this aqua pen again as I read, and you're going to see me put boxes around things. So I'm going to read, Leah walked 12.0 meters west. So I'm going to put an aqua box around that. But then my next number is 5.0 meters north. So I'm not going to put a box around that in green because north is a different direction than west. 6.0 meters west, I'll put an aqua box around that one. 15.0 meters south, I won't put a box around that one. Here's the one that's probably going to fool some people. I am going to put a box around 5.0 meters east. Here is why. East and west are both horizontal directions. And since they're both horizontal directions, I'm going to kind of combine them, but I just know that if I go west and then I eventually go east, they kind of cancel each other out. So because I have more west numbers right now, I'm actually going to pretend that they are positive. So I'm going to take 12 towards the west and add 6 more towards the west. So in my head right now I have 18, but I'm going to subtract 5 because that's going towards the east. And so since that gives me 13, I am going to pretend that all Leah did was walk 13 meters west. Even though she did more than that, actually she walked all around, we're going to pretend that she walked 13 meters west. Now, I'm going to pick up this pen, hopefully it shows up purple, and I am going to put a box around my 5 meters north. On my paper, it kind of split the line, so that's weird. But then I'm also going to put a box, same thing, around 15 meters south because north and south are both vertical. And so if you look at those two numbers I put in purple, again, one of them is north, one of them is south. So I'm going to do 5 minus 15. Just because 5 was listed first, I said positive. That gives me negative 10, but remember the reason I subtracted 10 is because this is going to the south. So that would mean I have 10.0 meters south because it ended up being negative. And so now I could add these vectors in this order if I would want. I could pretend Leah started somewhere and walked west first and then south. If I wanted to, she could walk south first and then west. But so that I can kind of compare things and see how people are doing, I'm going to put Leah's box for starting right there in the middle. Because of the order I wrote this in, I am going to draw my 13 meters west first. It's going to get me really close to the bottom of the page, guys, right now. Oops, I forgot to put my 13 on that line. Now I got to do my 10 meters south. Like I said, that's going to put me pretty much right at the bottom of the paper. And I'm still using the blue pen right now, guys, to draw in my hypotenuse. So let's do the work right over here. I got 13 and 10, which means I'm going to do 10 squared plus 13 squared equals h squared. So 10 squared is 100, 13 squared is 169. If I add those, I get 269 equals h squared, but I'm not solving for h squared, I'm solving for h, so the square root of 269. The hypotenuse length is approximately 16.4 meters, but remember that's just my size. 16.4 is just my size, so 16.4 meters. I now need a direction. Where did Leah start? And guys, I know I broke it down and only made it this simple one, but I'm going to put her theta right here because she started right here, and so this is the important angle. And so if I go across from that, I get 10. And if I go next to that, I get 13, which is why I'm going to find tangent inverse of 10 over 13. Once again, 10 was across from that. 13 was adjacent. Tangent inverse of 10 divided by 13. My calculator is telling me 37.56, so 38 degrees. Oh, guys, I drew this picture completely backwards for some reason. Give me just a second to get another piece of paper to actually draw it the right way. So far, it's not going to matter because all of my numbers are correct. Okay, all of my numbers are correct. 37.5 makes it 38 degrees. Okay, so I apologize greatly when I was looking at the paper and all that stuff. So I'm going to redraw it quick to actually go west. So sorry if you tried to stop me and correct me before and said, Miss Jabs, you drew that to the east. Thank you for doing that. Please remember, if I use Pythagorean's theorem, that's still going to give me 16.4 across the hypotenuse. So I'm not going to rewrite that work. I'll show you that work if I need to. But just now, I used tangent inverse to find that 38 degrees in there. All right, so sorry about my drawing being backwards for a minute. Thank you for trying to stop me and correct me. All right, but as I'm holding this up here now, please remember before, just a minute ago when I had Kaylin's, I said it's important to know we put where Leah started at the origin. So again, if I line these up, and this is why it was important that I had to redraw the picture, okay? If I line these up, which one of the quadrants does Leah's line up with? Leah lines up with 180. So this line right here towards the west, and you can start, some people might just start to know that, they don't always have to do that, is 180 degrees. Now again, if I draw that little arc in there by 38, that is going farther than 180, so this time I would have to add. All right, guys, so here's the deal. You know I'm in the Google Meet, right? I think today I'm going to tell you, I'm going to pause and I'll be there if you have questions and stuff like that. But if you are still having trouble knowing, why did she subtract for Kaylin's from 270, but in Leah's she's adding to 180? You're probably just sort of misthinking a little bit, but it always has to do with which one did you draw first. For Kaylin, think about it. For Kaylin, we drew south first, and south is 270. For Leah, after I drew it correctly, when we went to the west first, west was 180. So that's why these four numbers are the ones I want you to know. And guys, the reason we do need to remember both of these is because sometimes I go to the right and up. If I go to the right and up, I actually don't have to do anything because I would just add to 0. But if I go to the left and down, I would have to subtract from 360. All right, so just a few things there. But if we add those two together, I got 218. So Leah's resultant vector would be 16.4 meters at 218 degrees. All right, and guys, I know the video went a little bit longer today, but that's because part of the day, like I said, is a review. We are going to be taking a test or quiz or some sort of grade for that part of it again before we leave, before school is over. And a couple, I'm not doing any questions today to make you come back to the Google Meet if everything's fine. Right now, just send a little message. Maybe you want to pop back in the Google Meet and say, hey, Miss Jabs, I am done. But maybe you just want to send an email that says, Miss Jabs, I finished the video. So yeah, we're getting ready for a test, and just kind of be ready for that in the next week or so, because that's about all we have left of school. All right. I hope you guys are having a good day. Thank you. Bye.